Hello and Namaskar. Regression, linear regression, classical approach, and the case is find out the coefficient of correlation x bar, y bar and standard deviation of x if standard deviation of y is 12 and 16x minus 4y plus 160 equals to 0 and 15x minus 2y minus 95 equals to 0 are the line of regression. Now the first thing, we need to find out coefficient of correlation. In this kind of questions, there is a hidden question, and that is of finding the two coefficients of regression. Because without finding the two coefficients of regression, we cannot find out the coefficient of correlation in this kind of questions. So, to find out the coefficient of correlation, we have to find out the two coefficients of regression. And the two means on the basis of these two equations we can find out all these five things, and with the help of two coefficients of regression and available information of one standard deviation we can find out the another standard deviation. So first, to find out the coefficient of correlation we have to find out the two coefficients of regression. For that purpose we need to decide which out of these two is the line of regression of y on x and of x on y. As usual, I suggest to take the first as the line of regression of y on x and the second as the line of regression of x on y. Sometimes you may be curious, why should we take the first as the line of regression of y on x every time? In mathematics, it is the basic axiom, y is always dependent on x. So normally, the teacher, the paper setter or anyone gives the first equation according to our mathematical axiom only. So the first is normally of y on x. That's why I suggest to take it as the line of regression of y on x. And hence the second becomes of x on y. Yeah, deliberately it can be changed, but I don't prefer to change this kind of situations. Since this is the line of regression of y on x, first we have to make y the subject of formula. 16x minus 4y plus 160 equals to 0. Therefore, minus 4y equals to minus 16x minus 160. Therefore, 4y equals to 16x plus 160, because all the factors are negative. Therefore, y equals to 16x plus 160 upon 4. Therefore, y equals to 16x upon 4 plus 160 upon 4. That means y equals to 4x plus 40 or y equals to 40 plus 4x, whatever the order you maintain. Let us compare it with the standard form of the line of regression of y on x. That is y cap equals to a plus bx. B is 4 therefore, and b stands for byx. So byx is 4. Now the first coefficient is greater than 1. So it is necessary that the second coefficient of regression is less than 1 in such a way that the product of these two coefficients is between 0 and 1. 15x minus 2y minus 95 equals to 0 becomes the line of regression of x on y. So we need to make the x subject of formula. X will be 2y plus 95 upon 15. That means x is 2y upon 15 plus 95 upon 15. Therefore, x equals to 0.133y plus 6.33. Okay. Or that means x equals to 6.33 plus 0.133y. Let us compare it with the standard form. X cap equals to c plus by. That means b is 0.133. B stands for bxy, and that is also 0.133. Now let us verify. First, the sign of both the coefficients is same. Okay, must be same. Now one is greater than 1, so another must be less than 1 in such a way that product of these two is between 0 and 1. Let's check it through coefficient of correlation. The squared value of coefficient of correlation is the product of the two coefficients of regression. That means the squared value of coefficient of correlation is 0.532. That is between 0 and 1. So our assumption of believing the line of first as of y on x and second as of x on y is correct. Now to have the coefficient of correlation, we just need to get the square root of this value 0.532, and it is positive or negative 0.729. Okay, it must be positive because the two coefficients of regression are positive, so the coefficient of correlation must be positive. That means the coefficient of correlation for this data is 0.729. Now it is turn of finding the two means. By solving these two equations, we can find out the values of x and y, and they are respectively the x bar and y bar. But in this case it is minus 4y, in this case it is minus 2y. So we are going to multiply this first by 2. 15x minus 2y minus 95 equals to 0. Multiplied by 2, it is 30x minus 4y minus 190 equals to 0, or 30x minus 4y equals to positive 190. Now we are going to subtract this equation from this new one. 16x minus 4y equals to 160. Because of this minus sign of subtraction, this 16 will become negative from positive, this minus 4 will become positive 4, this 160 is negative actually. Yes, is negative, so it will become positive. 4y negative positive are cancelled. 30 minus 16, it is 14x. 190 plus 160 is 350. So x equals to 350 divided by 14. So x is 25, and that means x bar or mean of x is 25. Now we have y equals to 4x plus 40 or 40 plus 4x. If we substitute mean of x, the result will be mean of y. So y bar comes to 140. Thus we have both the means, and now we need to find out Sx. For that purpose we are going to use formula of Byx. Byx equals to coefficient of correlation into Sy upon Sx. Or any one of these two can be used randomly. Byx is 4, it is 0.729, Sy is given to be 12, Sx is missing. So we first need to Sx equals to 0.729 into 12 by 4. That will be the situation. So Sx is 0.729 into 3. Therefore Sx is 2.187 approximately. Thus we have now all the results: the coefficient of correlation, mean of x and y, and the standard deviation of x. But to find out the coefficient of correlation, we must first find out the two coefficients of regression. That's it.